Welcome to eDay11. Today is Tuesday. We are going to be doing systems of inequalities that are 2 by 2. They will all be lines. What I want to do is review how to graph a line. This first one is in our y equals mx plus b form. Just to remind you, we first plot our y-intercept at -3, and then we're going to use slope, and our slope is 2 or 2 over 1. We are going to move up 2 and over 1, up 2 over 1, and that will create our line. Our next problem, feel free to solve for y. I have no problem with you doing that and graphing as y equals mx plus b. I am going to show you another option for those who are interested. If you wanted to do with intercepts, an x-intercept is where our y is 0. If I replace y with 0, that will go away, and if you divide by 5, you get 3. And then if we wanted to find our y-intercept, a y-intercept is where our x is 0. 5 times 0 is 0, and then we finish solving, and you divide by 3 to get 5. Those are our x and y intercepts. So our x-intercept is 3, our y-intercept is 5, and connect the dots. Like I said, if you prefer to solve for y, you may. The next one is our horizontal line, and it's going to be a horizontal line at -8. And our last one is a vertical line at 7. So hopefully that's just a quick little refresher on lines. The next problem we're going to do is not a system because there's not 2 or more equations. It's just a normal inequality. But I wanted to take this time to review some things with our shading and dashed and solid. First off, we want to decide if it's going to be dashed or solid lines. Your dashed lines are when you have a less than or a greater than. Solid is whenever you have it equal to. So first off, let's go ahead and plot this. It's in y equals mx plus b. Our y-intercept is at 5. And then we have a slope of 3 over 1. So going up 1, 2, 3 over 1. And then I'm going to just reverse it so I can get one more point. As I connect my dots, because it does not have an equal to, I'm going to connect my dots with a dashed line. Now the next part we have to do is decide about shading. Shading is where your solutions would be. Some teachers teach it where you pick a point. Maybe you would pick the point 0, 0, and you plug in and say, is this inequality true? Is 0 less than 5? And you would say yes, true, and that means you would shade that half. You can work with it that way. I do it a little bit different. I find where my graph intersects that y-axis. And then I look at my inequality and I say, is this inequality a less than or greater than? And this one is less than. If I'm looking at my y-axis and I find my intersection point right here, and it says less than means I'm going to go down. And then you can start to see which half of the graph I'm on. Going down would be this bottom half here. Shading is where you have solutions. So any point in this shaded region would be an ordered pair that would make our solution true. So all of this would be shaded. And on the next page, they will ask us to find a possible solution. When they do, you want to write as an ordered pair, but it could be anything in the shaded region. In the next problem, we have 2 more to go. These are now systems. We're doing linear inequalities, so they're just lines. And you can choose whether you want to graph these using intercepts or y equals mx plus b. What I found over the years is most students preferred y equals mx plus b. So I'm also going to do that for you in notes. If we take this first equation and we want to solve for y, I'm first going to subtract my x, and I get the inequality y is greater than or equal to -x plus 4. Graphing this, start at 4. That's my y-intercept. And then I have a slope of -1. It has an equal to, so that means when I connect my dots, I'm going to do it with a solid line. In terms of figuring out where to shade, it says greater than. So I'm going to find where it touches the y-axis, right at 4, and greater than means I'm going to go up. And when I go up, I start to see which half of the graph gets shaded. Those are all solutions to just that inequality, but we have to graph the other one to find our solution for the actual system of equations. Graphing the next one. I'm going to give myself a little workspace over here. First thing we're going to do is subtract x. So -2y is greater than -x plus 6. And when we divide by -2, does anybody remember what we need to do? Whenever you multiply or divide by a negative, you need to make sure that you flip your inequality, and this would become a positive 1/2 x minus 3. So flip inequality if you multiply or divide by a negative, and that's super important. So now if we were to graph this problem, it's in our y equals mx plus b form. We're going to start at our -3, which is our y-intercept, and our slope is 1/2, so up 1 over 2. It is just less than, so I'm going to do it with a dashed line as I connect my dots. And less than, if I were to do my shading, less than if I find where I intersect the y-axis and I go less, I'm going to be going below. So less means I'm going to go down and I'm going to shade. Now remember that we want to know what the solution to the system is. We don't care about what we've done so far, it's helpful, but the actual question is what's the solution to the system? And that's where you want to show where they both intersect. It's not letting me shade, sorry. So you want to find out where both colors will intersect. Okay, I'm going to try this with something else. All right, we're going blue here. There we go. So technically, if we were looking for a solution to our system, it's just this blue area. The other stuff is just to help us get to that conclusion. From here, if we need a solution to our system, we're looking for any point in the shaded region of blue. So maybe I pick this point 9, 0. There's going to be lots of flexibility and options as we're picking a point. Anything in that shaded region is a solution. All right, so this next one, let's go ahead and solve for y. I'm going to subtract my 2x over. I'm going to be up at 5 as my y-intercept with a slope of -2 or -2 over 1. So I'm going to go down 2 over 1. It has a less than, so I'm going to make this a dashed line. And with a less than, find where it crosses that y-axis. Less means I'm going to go down, and that is going to tell me which half of the graph to end up shading on. Now, if you don't like to shade using this, feel free to just test a point, which maybe is how your teacher taught you in the past. Just pick a point on one half of the graph. If it's true, you shade there. If it's false, you shade the other half. Now, the last thing we need to do is graph this other one. This one looks a little different than what we've seen before. This is actually 2 vertical lines. If you want to look at it, we have one line here saying x is less than +3. And then over here, if you read this one backwards, it says x is greater than -3. And so we will end up shading between. If you look at it, your x is between those values. So we are going to be shading between -3 and a +3. Both of them have a solid line. So here's my positive 3, and then here's my negative 3, and my shading will be between them. Now remember, we're looking for our solution to our system. Our solution to our system is where you would see both of them, and it looks like it would be down over here. Let me pick a different color. Would pink show up any better? So down here would be our solution to our system. So technically, if we were to look, we would only have this pink part as our solution to our system. So what I need you to do on your homework is either bold in with your pencil or use a different color to show where your solution to your system would be. And then a perfect ordered pair that lands right in that pink shaded part would be 0, 0. Tonight's homework is eDay11. You have, this is just matching using a graphing calculator screen. And then it looks like we have a total of 5 problems to graph. I think that seems very doable. 39, you might have to change your scale, or I wouldn't even mind if you changed it just to like a 6, but I would just, you can change your scale. That would be fine. I would probably graph that one with intercepts. Doing x-intercept and y-intercept might be the easiest. Everything else looks pretty doable. Notice here, this one, instead of our vertical lines like we just did in our example, it will be between 2 horizontal lines. And then I left some graph paper for you. You can print this, you could do it on Notability, but please make your graphs accurate. And then you have the answers below, but just remember, I need to have accurate graphs with points plotted, dash solid, and shading. I hope you have a great day. This is our eDay11, and if you have any questions,